So let's talk about the Adjugate formula for the matrix inverse. Namely, we have this formula. There are many formulas or some formulas for the inverse of a matrix. Now we're going to talk about the Adjugate formula for the matrix inverse. Namely, this formula. You see the inverse right over here, and the formula says that the inverse of A needs to be invertible, is 1 divided by determinant of A. Now, how do I know that the determinant of A won't be 0? So I will divide by 0. The answer is just what I say, what I just said, that A must be invertible. And by definition, for invertible matrix, the determinant is not 0. So we know that this is defined, the 1 divided by determinant of A. Multiply by the adjugate of A. Now we need to talk about what is the adjugate of A, what is lies over here. In order to understand that, let's see how we calculate the adjugate of a matrix. The adjugate of a matrix defined by, let's do this matrix. Let's just calculate it and you will understand what is the adjugate matrix. So here is a matrix, for example, and what we're going to start calculating is what is called the cofactor in each position in the matrix. Now, what is the cofactor? It's exactly the determinant by using this row and column as you would do for determinant. And for each element in the matrix, we will calculate the cofactor. For example, for the first element, let's call this C11. So we'll create a matrix of cofactors. So for the first element, for C11, what we are going to do is take the determinant like we are taking the determinant of just the first row and column. So we'll take the determinant of this, right? This is how we are doing a determinant, by taking the first column and row. So it will be just this determinant. So it's 1 times 0 minus 6 times 4. So this is the first cofactor. C11, it is, if you calculate it, you'll get minus 24. So this is the C11 in the cofactor matrix. For C12, you are taking the first row and second column, and then you are taking the determinant of what is left, which is 0, 4, 5, and 0, which is 0 times 0 minus 4 times 5, which is right over here, with a minus sign, because remember, as we do the determinant, we're taking this and then minus this, right? Like we're doing the determinant, doing it by the first column and row, or by the first row. Okay, so C12 will be minus the determinant of 1 is left, and we will get 20. So for the C12, we get 20, and we can put it right over here. C13, again, now it's with plus, and again, the determinant of what is left from taking this row and column off. So we are left with 0, 1, 5, 6. And taking the determinant is 0 times 6 minus 1 times 5, which is minus 5. So for C13, we are getting minus 5. And etc. For all the other cofactors. So we are getting this cofactor matrix. And for general term, I am quite sure that there is a definition for a general C1j for the cofactor matrix, which is minus 1 to the power of I plus j. I plus j is defined by the position of the cofactor in the matrix, times the minor mij, the determinant of the remaining submatrix, as we did. Okay, so for example, you can find the minor m11. It's just eliminating the first row and column and take the determinant of 1 is left. This is the minor m11. The minor m12, for example, is taking the first row and column off and taking 1 is left. The determinant, this is the minor m12. Okay, so those are the cofactors. You can see right over here the determinant, that what is left for m12. As we did, don't forget the minus 1 to the power of 1 I plus j. So for m12, it's 1 plus 2. So you are getting the result. don't forget the minus and pluses, and you're getting the matrix for the cofactor for the example that I just showed. So this all was in order you to understand what is this adjugate matrix that we're going to use in calculating in this formula. Okay, so adjugate A, you find the cofactor matrix that we just show you how to build, and then you take the transpose. This transpose of the cofactor matrix is the adjugate matrix. Okay, you can see the adjugate A, the adjugate matrix or classic joint of A. This is the transpose of the matrix of cofactors of A. Okay, and we saw the cofactor matrix. Now take the transpose. This is the adjugate matrix. And determinant you of course know how to do and find, and this is how we can find the inverse of the matrix. Let's see a very simple example. This is the matrix. So we need the 1 divided by the determinant. So let's calculate the determinant. 4 times 6 minus 7 times 2, getting 10. 1 divided by 10 is 1 divided by 10. And the adjugate is very simple right over here. Of course, you can take the submatrices, and for example, for the first row and column, you take off the first row, you take off the first column. What is left is 6. The determinant of 6 is 6. So for the first value, you get 6. For right over here, for 7, you take off the first row, the column. What is left is 2. Don't forget to put the minus sign. So for the cofactor matrix, you will get here minus 2. Don't forget for the adjugate, you will take the transpose. So the minus 2 will be here in the adjugate of A. And you build this adjugate matrix and you get this one. And then you can apply the formula. The inverse of A is 1 divided by the determinant times the adjugate matrix of A. Okay, so here is the calculation. 1 divided by the determinant, adjugate matrix, calculate it, and get the inverse of the matrix. Now you can verify that we didn't make any mistakes by just calculating A times its inverse. You know it should be equal to the identity matrix by definition for the inverse. So you do this calculation and you really get the identity matrix. Now for a larger matrix, we'll need to find the cofactor matrix first in order to find the adjugate matrix, and we get the cofactor as we did with the minors, and don't forget the minus and plus and everything. We get the cofactor matrix. Now for the adjoint of A, we just take the transpose of the cofactor matrix, which is this one, and then we can, for this matrix, calculate the determinant. And when you do that, you get that the determinant of this matrix is 1. Again, it cannot be 0 because invertible matrix must have the determinant which not 0. So we can take 1 divided by the determinant, in this case 1 divided by 1. So you can find the inverse of A, which is 1 divided by the determinant, which is 1 divided by 1 in this case, times the adjugate of A, which is the transpose of the cofactor matrix that we found. And here it is. This is the formula. Now you can apply it and find the inverse of the matrix A. This is it. Thank you very much. This is how we can use the adjugate matrix formula for finding the inverse of a matrix. Okay? Thank you very much. Thank you for Gemini for writing it down using LaTeX and everything so it can be clear to you. I wish it was clear. If there are any mistakes or correction, please tell me. Thank you all for watching this video, and that's it for now.